Hi guys, this week's assignment is on the KT boundary, and that's also known as the KPG boundary. The KT boundary extinction event happened on a worldwide scale simultaneously, and some type of major event had to have changed dramatically in order for that kind of effect on the world to have happened globally. Almost all large vertebrate dinosaurs, plesiosaurs, mosasaurs, parasaurs, as well as several plants on a microscopic organisms, plankton, some tropical invertebrates, and they became extinct around 65 MA, which is right around the last part of the Cretaceous period. 75% of all kinds of different species on the planet became extinct. And this is why this time frame is often referred to as the Great Dying. This mass change had a really huge impact on the environment. Both the land and the oceans were drastically altered, yet somehow all of life was not destroyed. Most of the living things survived. But the smallest and the largest things that were alive during that time frame were both forced into extinction. This makes an argument that asks the question, what exactly happened? And how long exactly did it take to happen? And these are extremely difficult questions to answer. Now, there are two commonly agreed upon hypotheses about the event that led up to this worldwide change. The first is a major volcano eruption, and the second is that an asteroid hit the Earth. Now, we have a definite evidence that an asteroid, which is basically a large-sized meteorite, did hit the Earth at the end of the Cretaceous period. A meteor of this size would have burnt up when it entered the Earth's atmosphere, but it would have cut through it like a blade, heating the asteroid and melting some of the chemical compound makeup before the impact. And scientists believe that an asteroid of this size would have left a crater in the Earth that would be 20 times the size of an asteroid. The asteroid of this scale would have set off a series of events upon impact, such as tsunamis and earthquakes, and the skies would have been blackened with smoke and soot, leaving behind an empty crater of dirt, void of any kind of life that had once thrived there. Taking out several miles of vegetation that was grown on the land and in the sea, that would have had a great impact on the levels of oxygen to carbon dioxide ratio found within the air. This change with the air elements would definitely cause a lot of creatures and plants who rely on a certain specific carbon dioxide to oxygen ratio to go ahead and die off. The giant trees and vegetation destroyed from the impact, as well as those that are smothered by the mass amounts of soot from such an event, would ensure that this change would be permanent. We can find evidence of the massive asteroid crater hitting North America from Canada all the way down to New Mexico, the Pacific Ocean, the Caribbean Sea, and also in Europe. I did a lot of sites, I researched a lot of sites to obtain the information on this subject. However, several of them mentioned Walter Alvarez and his father, the Nobel Prize winner Luis Alvarez. One of the sites is Berkeley Lab at newcenter.gov. Walter Alvarez was a geologist that began taking some samples of the limestone rock back in 1977 that had once been below the sea level in Gubbio, Italy. The sample had a layer of red clay, which was thinly spread out between layers of rocks. And this red clay was void of any type of fossils, which was odd since the rock that was directly below the red clay had a large variety of fossils that belonged to several different types of marine creatures. And the rock sample found directly above the red clay held only one single species of form found within it. Walter's father, Luis Alvarez, was a well-known physicist. So Walter gave his samples to his father, Luis, to examine. And Luis and his team ran several studies trying to figure out how long it took the layer of red clay to form. They used a method called magnetic stratigraphy to date the reversals of the Earth's magnetic field found within the rock. Alvarez's study on the reversal of the magnetic poles did not have any kind of large decrease of sedimentation rates within the KT timeframe. The Alvarez's then took these samples over to a nuclear chemist named Frank Azario and Helen Michael. Azario and Michael created this technique called neuron activation analysis. And this type of testing ensures, it measures an extremely accurately, a really detailed concentration of elemental abundance within the red clay. And they compared that to both younger and older sediments that they had collected. They discovered that this was 25 times higher in the levels of iridium metals than those that were found in the 30 other samples they compared it to. Alvarez used the iridium as a measuring stick to date how long it took the clay formation found within the sedimentary rock to occur by comparing the foraminiferina, I don't know how to say that, extension before it reestablished itself. This discovery concluded that the red clay was created quickly, very quickly, and not naturally at all. There was an abundance of evidence proving that there was large amounts of iridium metal found within the red clay between the rock layers that were formed during the KT timeframe. There have been more than 100 places all around the world where the iridium has been found only within the KT boundary rock, which tells us that it had to be one giant event. And although iridium metal is found on Earth, it's really rare. Now, nowhere else really on the planet have we found such an abundance of iridium metal as the amount that was found within that KT timeframe. And we know that iridium metals are often found in meteor chemical components that make up, because of several different scientific studies have been done on these meteors. So the iridium metals that are found within the solar system is thousands of times more than what's found here. They are also trace fragments of glass found within the red clay, as well as large amounts of soot. Because the combination was so unique and not something that would have naturally been formed on Earth, the proof of an asteroid hitting had become very abundant. This massive worldwide deposit of iridium metal combination was likely a result from the huge debris cloud that would have formed after the asteroid collided with Earth. However, after Walter and Luis published their findings, a group of scientists argued that it was in fact a volcano that had erupted and left behind the volcanic rock that took out all the dinosaurs in India. The problem with this theory is that the scientists found shocked quartz and microkinetics along with the iridium and soot that could only be made when it was heated and caused a combustion during the catastrophic impact. So there's not a lot of data backing any kind of volcanic reactions. It's more likely it's going to be the asteroid. Anyway, I hope that this was helpful and clear. I hope everybody's having a really great semester, and I'll talk to you guys later. Bye.